This is a lecture for Statistics 252 on using the student's t-distribution for hypothesis testing. If you remember, for the hypothesis testing using z-values, you needed to have the standard deviation of the population. Of course, that isn't always available. When it isn't available, then you use the student's t-distribution, just like you did for the confidence intervals. So here we are using the student's t-distribution to find the critical values. You remember that for this t-distribution you had some tables. It was table F in the back of the book, also in Appendix C, and also reprinted in the back of the book. And I'll show you a little bit on how to use those tables. It's a little different than how you used them for the confidence intervals, but you will need to know the degrees of freedom. And the degrees of freedom are always the number, the size of the sample, n minus 1. And then instead of taking the test value into a z-value, I just say t, you take it into a t-value using this expression here. Remember, k is the value that you measured, mu was your assumed value, s is the standard deviation for the sample, and n is the size of the sample. The problem is that traditionally the normal body temperature, which was determined a long time ago, well, anyway, it was said to be 98.6, and this is questioned. Okay, so 501 subjects, they measured the temperature of the 501 people and found that the mean was 98.2, and looking at these 501 subjects and how the values were distributed, there was a standard deviation of 0.73. Now the research question is, or well, it should have been before you even did the research, is the normal body temperature lower than 98.6? So this is going to be a one-tailed test, even though it's t. The t-values can have the same, two-tailed, left tail, or right tail test. So now you have to give values for the following. What was the a priori value? It was 98.6. That was the value we had before we did any measurements. The test measurement came up with 98.2. It had a standard deviation of 0.73, and how many people in the test? 501. Now remember, for the t-distribution you need degrees of freedom, so 500 is for the degrees of freedom because it would be n minus 1. Then we state the null and alternative hypothesis, and this will be for a left tail test. The null hypothesis always looks the same. In other words, nothing changes. For H1, the true mean is less than 98.6. That's your alternative hypothesis for a left tail test. So for a left tail test, you have a distribution. Remember, it's a t-distribution, so it isn't really bell-shaped. It's kind of close to it at 500, but it's not really there. Okay, so these are t-values down here. And for the left tail test, you need a critical value. This will be a t-critical value. Let's put critical value here. And this will be your critical region. So if your measurement falls in this critical region, then you reject the null hypothesis. If it falls out here, then you accept it and say nothing changes. Okay. To find this critical value for t, you have to use the table in the back of the book. Here is the heading for the table in the back of the book. You see it says confidence intervals here, 80%, 90%. And somehow you think those relate to your problem, but they don't at all. So you don't even look at those unless you're doing confidence intervals. Instead, you look at these two rows. The one for one-tail test and two-tail test. Over here on this edge, if you look down the column, you'll see degrees of freedom is written out here. Degrees of freedom. Okay, you look over and find your alpha. Well, if the probability is 5%, and that's been fixed, then alpha is 0.05. So you can use this column right here, go down to the degrees of freedom, move over here, and that will give you your value, except that it's going to be on the left, so you need a negative sign. If you have a two-tail test and it was 5%, you would use this because the division has already been taken place. You don't have to divide by 2. Just find your alpha and decide if it's a one or two tail test. If it's a left tail test, then you have to add a negative sign. And now you have to sketch this. I'm sorry, you can compute this first. You have to take that test value of k and turn it into a t value. So that would be, I think it was 98.2 minus 98.6, and the standard deviation for the sample was 0.73, and it's divided by 501 because that's the sample size. And from that you find a t value. And I don't have any graph there in the homework for you to sketch on, so you just have to sketch something that looks roughly like a bell-shaped curve. At 500 it's going to look very similar to a bell-shaped curve. You don't have to graph a t-distribution, but it's going to look something like that. Hopefully a little bit better. Okay. And then you mark the critical value here that you found on the table. You shade that region, and then you use an X and mark where the temperature lies after you've turned the K into a T. That's what you're marking here. If it's in this region, you reject the null hypothesis. If it's anywhere in this region, you accept the null hypothesis.